Hello, in this video we're going to look at the orbital motion of our planets, key points in their orbits and also measurements that can be made. Now our solar system is made up of the Sun and 8 planets. Looking at it from an alien bird's eye view, there are 2 planets, Mercury and Venus, which are closer to the Sun than us, and we call these the inferior planets. Then there are 5 planets, Mars, Jupiter, Saturn, Uranus and Neptune, who are further from the Sun than us. These are called the superior planets. And it's best to view different planets at different points in their orbit, depending on whether they're inferior or superior. Let's start with our inferior planets. Those are the ones that are closer to the Sun than the Earth. Now there are a few key points in their orbit to consider. The first is when a planet is directly between the Earth and the Sun, like here. This is called the inferior conjunction. This is the point where a planet would transit the Sun and can only be seen on the inferior planets. Then as a planet continues its orbit, when it's on the direct far side of the Sun, we say that it's at superior conjunction. Now, there are a couple of other important points. When an inferior planet is at a right angle between the Sun and the Earth, it's at its elongation. Here, the planet Mercury is at its greatest eastern elongation. This is one of the best times to observe inferior planets, and they would be at their best in the evening sky. Now, I said there are a couple of points. The other is the same point, but on the other side, and this would be a planet's greatest western elongation, and this is another of the best times to see a planet. At this point it would be at its most west of the Sun and would be best to see in the early morning sky before sunrise. Now let's move on to our superior planets, those that are located further from the Sun than the Earth. There are 2 key points in their orbit that you need to know about. The first being here, when the planet is on the opposite side of the Earth than the Sun. This is known as opposition. Alternatively, when the planet is on the same side of the Earth as the Sun and would be behind the Sun, we know this as conjunction. The best time to observe a superior planet is when it's at opposition, and this is when the Sun's light would reflect back best to an observer on Earth. Now, you need to be able to use your skills of logic and maths to be able to work out some distance-based question. So here the question is, how far away from Earth is Mercury when it's at inferior conjunction? Now you'd have values on your datasheet to help work this out. So when Mercury is inferior conjunction, it's here between the Earth and the Sun. And we want to work out this distance in astronomical units. So using the datasheet, we can see that Mercury is 0.38 astronomical units away from the Sun, and the Earth, of course, is 1 astronomical unit away from the Sun. Therefore, we can see that to work out distance x, we just need to take 0.38 away from 1. This means that Mercury is 0.62 astronomical units away from the Earth when at inferior conjunction. Let's take another example. Let's use some of the information in the question. So the question tells us that when Jupiter is at opposition, here, it's 4.2 astronomical units away from the Earth. But we want to work out the distance when it's at conjunction, here. Well, we know that the Earth is 1 astronomical unit away from the Sun. And so therefore we know that Jupiter is the total of that, which is 5.2 astronomical units from the Sun when it's at conjunction. So therefore, to work out the distance between Earth and Jupiter at conjunction, we simply need to add the 2 values, 1 plus 5.2 astronomical units, to give us the fact that Jupiter is 6.2 astronomical units away from the Earth when it is at conjunction. Now you're confident using astronomical units to measure distances in the orbital motion of the planets, give our key questions a go.